Dear all, welcome to my talk on privacy-preserving attribute-based credentials for 6G networks. My name is Andreas Kunz from Lenovo, and I apologize already that I cannot be in person in the room. I'm presenting this work on behalf of my co-authors from the University of Murcia and Lenovo. I will give you here a short outline of this presentation. First, I will explain a little bit the privacy-preserving attribute-based credentials, or short PABC, in terms of principles and the architecture. Then I will show how we integrated the PABC idea into 5G Advanced in terms of credential assurance and network registration. And then I will give you a short overview about the Rigourous project and what we will do with the privacy-preserving attribute-based credentials in Rigourous. I will conclude then on the last slide. Privacy-preserving attribute-based credentials are, in fact, digital identities which have credentials which contain a list of signed attributes. Those attributes could be, for example, the name, the age, a credit card number, or anything which is an attribute of an individual user. The user has the control about what attributes or subsets of attributes of a credential to disclose to some service provider as a verifier. These attributes also can be disclosed according to a policy and without revealing the real value of an attribute. So there could be things like the proof of range, like if a online shop wants to verify that you're over 18 years old, and the policy would only reveal a yes or no instead of the real age. Or it could be like proving the membership of something in this direction. One principle of ABC is the unlinkability. This is achieved with zero knowledge proofs. This means like a user can convince a service provider that it owns a credential without showing the full credential to the service provider. And it is also not possible that two generated proofs can be linked to the same user. And this is the unlinkable criteria. Another one is the privacy. This is achieved so-called pseudonyms, which are generated from the user's public key. It is assumed also that the user can generate an unlimited number of public keys and thus can derive an unlimited number of pseudonyms. The PABC architecture consists of 5 actors, which are the issuer, user, and verifier, which is the service provider, and the revocation authority and the inspector. The user will receive a signed credential from the issuer with all the attributes, and the user can use then this credential to generate a presentation token for the service provider. This means the verifier. To receive a specific service, the verifier can verify this credential based on the issuer's public key, its policy, and the revocation information. The revocation authority will set the revocation information and parameters, and the inspector can reveal protected attributes and if, for example, some abuse is happening as a kind of legal interception. This call flow is about the credential issuance of the PABC credential, which is the basic stack before usage. In our case, we want to issue a network access-based credential. The issuer could be also, in this case, seen as a web shop, a trusted web shop where the user will buy data network access of a specific network or a specific access network technology, and for a certain time. So in the beginning, the user first creates a public private key pair and sets the attributes of the credential, for example, what kind of network access type, mobile network name, and so on. It will send the credential to the issuer. The issuer will verify all the attributes, will set the revocation parameters, for example, the time and the volume. The issuer will then initiate a root key generation request to a key generation function, and which is then sent back, and the root key will be encrypted with the user's public key, and the issuer then will send a credential revocation issuance request to the revocation authority to verify that the revocation attributes are set correctly. And then, after all, the issuer will sign the whole credential and will send the credential back to the user, including the encrypted root key. This slide explains the network registration call flow, where we integrated the PAPC into 5G Advanced. There are some differences because the user has no subscription profile in the network and is there basically not known. So the UE will send a registration request to the AMF. The AMF will send the ABC presentation policy back and includes the AUSF public key. The UE will generate then a presentation token and will send a NAS request to the AMF. The presentation token includes the ZUPI, which is generated as an ABC pseudonym, and the root key. Both are then encrypted with the AUSF public key. The AMF, when it receives the presentation token, will check the validity with the issuer's public key. Then it will check whether the revocation parameters are still valid and the credential is not revoked. After that, the AMF will send an authentication request to the AUSF, and the AUSF will then deconceal basically the SUPI and the root key. We'll select the authentication method and generate an authentication challenge. This is then sent back to the AMF, and the AMF will then send the authentication request to the UE, including the authentication challenge and that the presentation token was successful. The UE will then, with the selected SUPI and root key, generate the authentication response and will complete the authentication procedure. And then the AMF will initiate the security mode command procedure, and afterwards it will provide a 5G GUI to the UE, which is then used as a temporary identity for further access to the network. Rigourous stands for Secure Design and Deployment of Trustworthy Continuum Computing of 6G Services. It has different features in the design and operation framework. It has different integrations of the different services, information and infrastructure layers. And there are a few main pillars of this architecture, which are zero-touch network and service management, zero trust by design, the security orchestration, automation and response cycle, DevSecOps, and AI as a service. The goal is to achieve cyber attack response and mitigation with various technologies. PABC is also used in Rigourous in different ways. One feature is the IoT bootstrapping and onboarding, where we design a zero-touch device bootstrapping, where the device can connect to an onboarding network with default credentials, and then it can connect to the issuer after the authentication with the onboarding credentials. The device then retrieves long-term credentials from the issuer in form of PABC credentials, and afterwards the device can connect using the PABC credentials to the serving networks described in the attributes of the credentials. Another feature is the trusted application onboarding, where the device can securely connect with its PABC credentials to an application policy server. This application policy server will send information about secure applications to the device, and that needs to be installed on the device. And later on, when those devices are in the progress, or before installing already on the device can verify whether the application is a genuine one or a malicious application. To conclude, we can say that the PABC credentials offer privacy and security for access-agnostic network registrations. The PABC concept can be integrated in 3GPP with the ABC framework of issuer, user, verifier, and revocation authority. With this new concept, the subscriber is not owned by the mobile network anymore, and the user has now the freedom to choose their favorite network to connect to. We need to carry out further work on the K-root refresh. At the moment, we have bound one K-root to one credential, so it can be used only with one network to achieve the unlinkability criteria of ABC. And we need to carry out more further work on the trusted application onboarding. This work was sponsored and supported by the European Research and Innovation Programme and under the Rigourous project. Thank you very much for your attention, and if you have any questions, please just send me an email. Thank you very much.